explanation will be more personal and I can explain more. I have more time to do it. Okay, don't afraid that. Yeah, so we should be very close. Yeah, so you have to any problem you have to let me know. Yeah, this course, if you do it, you spend time on that, you will get good results. Yeah, don't worry. Yeah, but if you are say that, oh, yeah, so difficult, so abstract, yeah, I don't like programming. Yeah, then this course will kill you. So spend time on that. Go to the LAMS and then understand that. Yeah. Okay, so we studied tutorial number 1. So we have 7 questions. Yeah, so it's very simple. Yeah, so we can, this one is very simple. So you have the sequence. You want to describe it as increasing, decreasing, non-increasing, and non-decreasing. Yeah, so let me get the pointer first. This pointer, right? So you have increasing, decreasing, non-increasing, non-decreasing. Yeah. So you look at the first one. Yeah, you have actually it's increasing. Yeah, but you have 2020, 2020. They don't increase in that sense. Then what you can say is non-decreasing. So non-decreasing. So the answer is non-decreasing. I think the others are quite obvious. So this one is decreasing, but sometimes you see minus 2020, minus 2020, they are the same. So we cannot say that is decreasing. So we say non-increasing. Yeah, this one I think is very obvious. So this one here, increasing. Yeah, this one here, right? No repeat. Yeah, so increasing. So this one, 5 and 5, so you cannot say that is increasing. You cannot say that is decreasing, is non-increasing or non-decreasing. So what you can say that is non-increasing and non-decreasing. So like that. Sometimes you say that may be a constant, something like this. Yeah, but I don't see any description called constant here. So I use the non-increasing and non-decreasing. So this one is just warm up. So no difficulty. This one. Okay, any question? Next. Now, next is find the, okay, first of all, LG is the log, the base is 2. So we use a shorthand notation called LG, right? Actually is equal to log base 2. So when you take the log 64, you should express 64 to be an exponent, 2 to the power 6, right? 64 is 2 to the power 6. Log means to get the exponent. So what it means here is like that. You see that 64 is equal to 2 to the power 6. And the log is go to get the exponent of that. The exponent is 6. So the answer is 6. So you apply to here, to part 2, you will see that this one is go to get the exponent when the base is 2, right? So 2 to the power 1000, yeah, so you get the exponent is 1000. So the answer should be 1000. Very simple, right? So not difficult part of that. So any question? So take the log. So first of all, you have to know what does it mean. The LG here, LG is the log base 2. So it's a shorthand notation defined by Prof. Wong's book. You go to the book, then you see that he defined it. Yeah. In other books, also they define it. Yeah. But sometimes it may be they put the full form or whatever. Yeah. So the shorthand notation is like that. Once we define it, it should not be a problem. But this one is not universal. You read other books, they may not have this notation. Okay, so we go to question number 3. Question number 3 is to find the floor value and the ceiling. Yeah, The floor value is the integer just above that. Yeah. So this one is 37.99. Above it, the most nearest one is 38. So so this one, the ceiling is 38. The floor is the integer part of that is 37. Yeah. So it should be like that. The floor should be 37. Yeah, because the one just below it, yeah, is 37. The ceiling is 38. So this one is a function. So we introduce function because later on when we do some proof, all this, we need this kind of notation to help us. They are carefully selected. Yeah. So we'll use it later. Okay, so this one here, what will be the floor? The floor is the integer part of that. The integer part of that is 3. The ceiling is, you see that the ceiling function is the one just above it, so it's 4. Okay, I think this one is not difficult. Once you see it, you know what it is. Yeah. So these two functions, we use it later. Okay, any questions up to now? Next one is the determine the following expression whether it's correct or not, right? It's true or false. Now, so when you do it, you should do it from one side to another. So you can do it from the left-hand side to the right-hand side, or you can do it from the right-hand side, go to the left-hand side. Don't mix them, you see. Don't expand the left-hand side equal to expansion of right-hand side and cancel some term and then do it. It's very difficult to see if it's something like that, you see, because later on I will talk more about that. So you should try to do it from one side to another, and then from n factorial, after some manipulation, you will get the right-hand side like that. Or you can go to from the right-hand side, after some manipulation, you get the left-hand side. Then the one is very clear. The marking is easier. If you don't do it like this, wow, this is very chaotic. Yeah. So you put a question mark here and expand the right-hand side, expand the left-hand side, cancel out some terms. So at the end, I see that very difficult to give marks. So not very easy. So help me. Okay, so how do we do it? So I do it from the left-hand side. From the left-hand side is n factorial. By definition, n factorial is n times n minus 1 times n minus 2 times n minus 3 and so on until 1, right? But you look at the last product here, the last n minus 1 term, the product of that. This is exactly the definition of n minus 1 factorial. So you can replace this one by the definition. But this is n minus 1 factorial. So n times n minus 1 factorial is what we want to prove on the right-hand side. So they are exactly the same, right? So we'll say that this is true. So you learn from that. Of course, you know the answer to this one. You learn from that is you try to do it from one side to another. Make the logic easier to understand. Okay, so when we do it, when we prove it, we will try to do it in this way. Sometimes you put this one and then you have the right-hand side, you expand it and cancel out some term is 1 equal to 1. So this is true. Of course, this one is also one way to do it, but not quite easy to mark. You see, sometimes the logic is wrong. You see, we'll create some very difficult understanding. Yeah, so try to use this way to do it. because sometimes along the way you will change your one. Say 10 is greater than 5. And then you say that, oh, 5 is less than 100. Then you take part of it, 10 is greater than 100. Wow, then I can see that every step is correct, but sometimes it's not correct. Yeah, so 10 is greater than 5, and 5 is less than 100. Then you group them together, say 10 is greater than 100. Wow, so a lot of proof, they do it like this, make it, the logic is not difficult to not easy to understand, and at the end you will create some fallacy. Yeah, so not, I don't know whether it's right or wrong. You see, sometimes yeah, from my feeling is wrong. Yeah, but how come you can prove it? Yeah, so I have to spend a lot of time to trace it, say that, oh yeah, some steps you are wrong. Yeah, so try to be clear, very clean, from left hand side to right hand side, from right hand side to left hand side. Either way will do, but don't mix them together. Yeah, once you mix them together and then put a question mark on top of the equal sign, then you try to cancel out some terms. Sometimes it's very unpredictable. Yeah. Okay, so you should not put yourself in a difficult position. Okay, so this one is another proof. We'll do it from the left-hand side to the right-hand side. Okay, so you can do it from the right-hand side to the left-hand side. Okay, so it's like that. The definition of this one is like that. Is n factorial. Okay, this is upstairs is n factorial. Downstairs, you get the r. R is r factorial. The second term will be the difference between them. The difference between them, n minus r factorial. So this is the definition of the n choose r. N chooses r is the definition is like that. In combination, I think you know that, so I don't explain like that. Now, I exchange these two positions. For the product form is okay. A times B is equal to B times A. So nothing wrong. Okay. Then you see that this one is the same as this one, but this one has been changed. How do I change? I change it to n minus n upstairs minus n minus r. So this one is the definition of like this. So is n factorial. This one will be this one here. So we'll put it here is equal to this one, right? So is n factorial. N minus 1, you have factorial, and the difference between them is here. So it's another definition. It's very clear. So you come back to this expression on the right-hand side, and this one is correct. Yeah. So you look at it may be very simple. You know how to do it. But sometimes we follow the definition of this one. And then this one is follow the definition is n chooses n minus r. Yeah, so it should be clear at this point here. So that's why sometimes you miss the tutorial, some key points that you will miss it, may not be that complete. So if you can try to attend the class. Okay, so this is question number 5. So it's very fast. You see that half an hour, we will finish it. So in this class here, you have only 2 formulas. You have to remember. This is one of them. Is the one is the series, right? You add them together. This one is another one, the geometric sum here. So you'll see that this one, how do we get this one? Well, you from the class note, from this class note and the lamps, you know that how to do it from 1 up to this one. So you know that is a geometric series. Yeah. So you have the formula. Now this formula you need to remember. You need to remember 2 formulas. This is one of them. Okay. Don't argue with me. How come you ask me to remember something? Yeah. This is very basic. Yeah. Very basic one from there you can derive a lot of things. Yeah, so this is one of the necessity for this course. Don't argue with me. So you have only to remember two. Okay, this is one of them. So apply the formula for that, then you get the answer. The answer is like this. Of course, the ratio is R, so it's R minus 1. R minus 1, right? R is 2, right? So this one is 2 to the power, the last one, I minus 1 plus 1 minus 1 here. So you know how to do it. This one is I minus 1, so you have to upgrade add 1 to it and minus 1. And this one is 2. 2 is the ratio, the R minus 1. After the simplicity, downstairs is 1, right? So the upstairs, you simplify it. I mean the numerator, you simplify, you get this answer. That's all. Yeah. So this formula you need to remember. You need to remember, because later on when we do some proof in the course, we need that. We need that. So you will see that in the exam paper, we will never give you this formula. This formula is not there, because you will need to remember two in this class. Okay, this is one of them. Not difficult. I see. If you still remember what you learned in high school, well, I think this one should be one of them. Okay, so this one is like that. The other one, okay, question number 7. Number 7 is the mathematical induction. Mathematical induction. To prove that each question is true and for every integer value of n. So that means for every integer of n, that means if n is equal to 1, this is true. For n is equal to 2, this is true. For n equal to 5, this is true. For n equal to 100, this is true. So we have to prove it. So what should we do it? Yeah, so I think you have learned that. If you haven't, you are not from IB, so you may not have learned that. That doesn't matter. I think someone told me that O-level, they don't teach this one. Maybe true, but I teach you now. So there are two steps. One is called basis steps, the very basic one. The other one is called inductive steps. In the basic one, basis step, you find the smallest value of n. So positive integer of n, the smallest value of n is equal to 1. So you will check 1 whether it's correct. If this one is for positive integer n greater than 10, greater than 10, greater than or equal to 10, say like that, then the smallest value will be 10. So you should apply 10 to that. So you have to check which one is the smallest value. You should build the foundation first. The foundation is what's the smallest value of n. Not always start from 1. Sometimes it may be start from 5. Say that for n greater than or equal to 5. Then your first basis step should be for 5. Check it. Okay, but for this one, n is equal to 1. So we start from 1. Okay, so we look at the left-hand side, which is equal to 1 times 1. This one is equal to 1. This one is 2 factorial is equal to 2 minus 1 is also 1. So you see that the left-hand side is 1, the right-hand side is 1. So the left-hand side and right-hand side are the same. So we conclude that the statement is true as the left-hand side and the right-hand side are both equal to 1. So this is the basis step. We have to go to check what will be the starting value, the initial value of n, which is 1. Then we start from 1. So you have to be careful, you have to be smart. Don't always start from 1. You will look at the question. Okay, the other one is called inductive step. Inductive step is because this one, this statement is 1 is true, 2 is true. When n is equal to 100 is true. When n is equal to 1000 is true. So we cannot just prove 1 when n equal to 1 equal to 2. or equal to 100, equal to 1000, and that's all. We conclude that this statement is correct. We cannot do it like that. So the proper way is to assume that K is correct. Assume that K is correct. N is equal to K, K is correct. And based on that, we prove that the one K plus 1 for N K plus 1, this is true. So the logic is like that. If N is equal to 1 is true, the next value will be 2. If this is equal to 1, then 2 will be true. Once 2 is true, then K becomes 2, right? Then 3 is true. When 3 is true, then this one is 3, then 4 is true. You do it like that, is like you every time you add 1. So that means all the possible value of N should be correct lah. So this is the logic behind it. Think about that, yeah. Not just know how to do it, yeah. Okay, so we assume that this is true. We try to prove that. Now, when we prove that, what we want is when N is changed to K plus 1 is here. Then you see that the right-hand side should be N is equal to K plus 1 plus 1. So it's K plus 2 factorial. We want to prove that. We want to prove that. This one is we want to prove. So you can go from the left-hand side to the right-hand side, or from right-hand side, go to the left-hand side. Don't mix them. Once you mix them, you have to pity me. I have to mark your question. Very difficult, and sometimes you will have some very ridiculous conclusion. Yeah. So try to do it from one way to another. Okay, so like that, yeah. And we assume that when N is equal to K is correct. So that means it's this one. This one is our assumption. So we apply this one to the previous one, the left-hand side. So you see that the left-hand side is like that. It can break into up to K plus the extra term. Yeah. So up to K is given by that, right? The summation up to K is given by that. So this one is here. This one is the extra term because you are talking about K plus 1, right? One more term compared to this one. The extra term is here, is K plus 1, and I is K plus 1, and then times K plus 1 factorial. Okay, I put a times here because if you bracket, you don't have it, so it looks a little bit confused. I try to put the cos sign here, the times here. Okay, so now I pull out the K plus 1 factorial. K plus 1 factorial, this one has 1. This one has the factors K plus 1, we put it here. Minus 1, we put it at the end. So after the simplification, this one is K plus 2, right? This one is K plus 2 times K plus 1 factorial. So from previous verification, we know that this is K plus 2 factorial minus 1. And this is exactly the one we want to prove on the previous page. The previous page, so we want to prove that. So now we conclude that this is correct because we have 2 steps. One is the basis step, the other one is inductive step. So this one is true. So this one is the remark here. The design expression is obtained. Normally, we prove the equation from the left-hand side to the right-hand side, or vice versa. So for mathematical induction, this is the proper way to do it. And help me. So otherwise, you have your very wonderful way to prove it. I may spend 1 hour on that, still don't know whether it's true or not. Yeah. Okay. So if you do it from one side and go to the other side, then make my job easier. Make your job easier. Yeah, you're very clear cut. Yeah. Okay. Or you can go from the right hand side to the left hand side. I also welcome that. But don't start from here and then you put a question mark and expand the left-hand side and expand the right-hand side and cancel out some terms. So at the end, it's very difficult to see. Okay, so any comment on that? Next one. Okay, next one is also a mathematical induction, but is inequality. So we'll have two steps, the basis step and the inductive step. And this one here, the starting value of n is equal to 1. So we have to check equal to 1. N is equal to 1. So you have to be smart enough to see that what will be the starting value. Yeah, sometimes it's not necessary 1. I have to emphasize that. So you look at the left-hand side is 1 plus x to the power 1. The right-hand side is 1 plus x. They are equal. So it's still true because this one is greater than or equal to that. So one of them will be, if this is greater than, fine. If this one is equal, also fine. So this statement is true. The equation is true for the starting value n. Okay. So now we'll use the same method to do that. We assume that when n is equal to k is correct, and then we will extend it to k plus 1. Okay, so this is what we want to prove, where here n is always greater than minus 1. Okay, so you look at it. What will be the use of this one here? The use of this one is like that. If n is greater than or equal to minus 1, you add to 1 plus 1. This is always greater than 0. So this is positive, non-negative non-negative. So this term cannot be negative value, because when you do the inequality, once it's negative, then the sign will change the direction. Okay. Okay, so now here, this is the assumption. When n is equal to k, this is correct. So this one is the assumption here. 1 plus x raised to the power k is greater than or equal to 1 plus kx here. So now we'll try to prove. This time, I from the left-hand side, I go to the right-hand side. It's like that. You look at it, 1 plus x raised to the power k plus 1. So is equal to the product of them, right? Equal to product of them. Equal to the product of them. This 1 plus x. This one is 1 plus x to the power k. Now by the assumption here, this one here is greater than this term here. So we'll apply this one to here. So, but this one is greater than 1 plus kx. So this one, we apply the assumption, put it here. Okay, so you have 1 plus kx, you have 1 plus x. So you expand it, you get 4 terms, right? So 1 times 1 is 1. 1 times kx is kx. 1 times x is here. Kx times kx is x squared. So you have 4 terms here. So if we ignore the last term, you ignore, cancel this one, ignore this one. So this one should be greater than these 3 terms, right? Greater than these 3 terms, because this one cannot be negative, right? As what we expected, right? This one cannot be negative. X squared always non-negative. K is positive integer. So this term cannot be negative. Okay, so this one non-negative, you ignore it. So these 4 terms should be greater than the first 3 terms here. The first 3 terms, you group them together, you get something like that, which is exactly the one we want to prove on the next page, right? On the last page. So then from here, we see that we have find the answer. So it's obtained, so it's For this one, maybe it's easier to prove this inequality from the left-hand side to the right-hand side. But sometimes it's not true. You say from the left-hand side, from the right-hand side, you can go to the left-hand side. Okay, that's all. Any questions? You can ask me now, or you can use the chat to tell me that you have some doubt about that. Yeah. Remember the mathematical induction. Do it like this. Use two steps. Because many of them they don't check, they don't do the basic step. The last term, the last sem, we have the one question on that. I think is just give everyone 10 marks lah. But at the end, many students they don't have the basic step, and then when they prove it, they prove their own way. I don't know where they learn it. So they learn it in a very different way. So give me a hard time. You see, I use 3 days to mark the question. Yeah. So every time very headache. Yeah. Some of them, most of them are correct lah, but some of them they have some very difficult time for me lah. So they may do it like this. So very creative. Yeah. So I don't know what to do. Say that 10. So they say that is greater than 5. Okay lah. Yeah. And then they will say that 5 is less than 100. Then they conclude that 10 is greater than, because they use here, they put it here. They use here. Where's my pointer? The eraser. Okay, let me clean this one first. They may say that this one is greater than 100. Wow, then I look at it, it seems that every step is correct, yeah. But the conclusion is very chaotic, yeah. So I cannot believe it. So I go to check. Very difficult to check, yeah, because the expression is very complicated, yeah, a little bit complicated. Then at the end, I know that the answer cannot be true because different from my model answer. So I use a very difficult time to find that, oh, inside this step, they have some very strange idea to do it. So at the end, they can give you very simple one. 10 is greater than 100. Wow, so very eye-opening. Yeah. So sometimes like that. Yeah. So don't try to do it, because you start from 1. You should keep doing that. Yeah. So if this one is greater than 1, say like that 10, at the end you say that 10 is greater than 1. It's fine. It's fine. That one. Yeah. Don't try to mix them. Sometimes it's greater than, and then you have some other idea is less than something. Yeah. All of them are correct, but you group them together may be different. Yeah. Okay. So there's a question. Yeah. So good lah. Yeah. So. Oh, inductive portion. Okay, let me repeat this one again. We have time. Yeah. Yeah, it's correct. So this one is like this, right? Yeah. So you for the first one, we can also do it like this. So first of all, you search for the smallest value of n. For this question here, n is equal to 1. Then you check the left-hand side, the right-hand side, they are correct. So you say that this one is true for the initial value, 1. Then now you assume that n is equal to some value called k. K. Then you try to expand it to upgrade it to k plus 1. So the assumption is this is true, and you extend it to k plus 1. So the idea is like that. If 1 is true, then k is equal to 1. That means 2 is true. when 2 is true, then 3 is true, and so on. In this way, all the integer value will be correct. Yeah. So this one is what we want to prove. You can do it from the left-hand side. How do I get this one? Is from here. You look at it, n is equal to k plus 1. N is replaced by k plus 1, so it's k plus 2 lah. So this one is what we want to prove. You can go from the left-hand side to the right-hand side, or from the right-hand side to the left-hand side. But look at it, this one is easier to do it from the left-hand side to the right-hand side lah. So when we do it, so you see this is the assumption here. So we start from the left-hand side. The left-hand side, you see that I is equal to 1 up to k plus 1. So you can split this one up to k only. That is the first term, plus the extra term you have compared to this one here. You have one extra term. The extra term is corresponding to k plus 1. So you put it here. The k. So this one is the first k term. This one is the k plus 1, k plus first term here. For the first k term, by the assumption, you have this expression, you replace it, you know that this is correct, and now you group them together. So you group all of them, then you see that this one, you add them together is k plus 2, k plus 2, and then it's k plus 1 factorial minus 1 here, because this one, you put it here. This one, k minus 1, k plus 1 factorial, you have 1 here from here. You have k plus 1 from here, you are here. You group them together, it must be k plus 2 lah. So from the previous one, you know that this is k plus 2 factorial minus 1. So this is exactly the one we want to prove on the last page. So we conclude that this is correct lah. So the remark here is you can go from the left to the right, or from the right to the left, up to you. But try not to mix them. For the next one is part 2, is another one is inequality. So you have to search for the value of smallest value of n, which is 1. Then you say that the left-hand side and the right-hand side are equal. So it's still correct. So this one is still correct. So we conclude that the equation is true. Yeah. So now we'll assume that k is equal to n is equal to k is correct. We assume that and try to extend it to k plus 1. So that means you base on that change n to k plus 1 here. So this n will be changed to k plus 1. This is what we want to prove. Here the assumption is another one is x should be greater than minus 1. So what is the use of this one? The use of this one is in this way here, 1 plus x, it itself is non-negative. Yeah, so non-negative. Okay, so this is non-negative. Okay, so this is our assumption. When n is equal to k, this is true. That means this inequality is true lah. Then we'll go from the left-hand side. So from the left-hand side, you can split this one into a product. The first one is raised to the power k only. Then the extra one for 1 is here. So this one, we can use the assumption to do it. The assumption is that when this is equal to k is correct, right? So we can use this one to help us replace this factor here to 1 plus kx. But this one has to change the sign to greater than or equal to, like that. So you have the extra 1 is 1 plus x here. So you see that you expand it, you get 4 terms here. This one is equal to the previous one. So this one is correct, yeah, right? So you have 2 terms times 2 terms, you have 4 terms here. But now we want to ignore that in order to get the answer. When you ignore that, you have to argue that this one is non-negative. This one is always non-negative, greater than or equal to 0. So if you ignore this term, this 4 term should be bigger than the first 3 terms. after the manipulation, you see that this is correct lah. This is exactly what we want to prove. So we conclude that this statement is true, and it seems that the proof is easier from the left-hand side to the right-hand side. Okay, any other questions? Okay. So you have any question, don't hesitate and send me some email or call me and try to contact me to solve your problem. Solve it earlier, then your job will be easier. So at the end, I stop at this point. Later on, I receive the link I will send to you through the tutorial group. So everyone will see it and use it as a reference. Yeah, don't try to abuse that. Yeah, because you have the recording, you have the whole world, and you don't need to come to the online class. So I think this is not a good idea. Okay, thank you very much. See you next week. Group A, come to the class earlier because you are late for the IRA. I cannot help you. If you come later, I will not give you the makeup. If you come the last 20 minutes to take the IRA, say that I will sit at a corner and then I will not affect you. I don't like it. So if you want to take the IRA, Group A student, you come earlier. Group B student will wait. Yeah. So our class will not start at 9:30. Probably will 9:40, 9:50, 9:48, or something like that. Yeah. So about 15 to 20 minutes delay. When I finish the IRA, I will open the Zoom and then everyone will see me again. Is it okay? Okay. Thank you very much. Yeah.
Oh, Prof.
Yes.
I have one question.
Yes.
Yeah, so for basic step, right? How do I know for basic step? How do I know what number to substitute for n?
You have to look at the question. Say that is true for n greater than 100. Then you start from 100.
Oh, okay.
You have to look at the question, understand the question. Say that for all even number, say like that. Then you see that. Then you have to start from 2 something like that, right?
Okay.
So
but for this question, right? For this. That's okay. I'm done. Thanks.
Yeah. So basically, you don't know which one to start. You have to read the question. What will be the smallest value? Once you know the smallest value, you assume that this is correct, and then then this one will be the K. The next one will be there.
Must it always be smallest value?
Because you assume the smallest value, the inductive step will make sense because the smallest value is correct. Then the smallest value plus 1 is correct, right?
Yeah.
Then this one becomes the smallest value plus 1. So like that, if K is equal to 1, 2 is correct. Then this one is changed to 2. Then 3 is correct, right?
Yep.
Then 3 is correct. Then 4 is correct. Then you look at it, is like those 1 to push to the end. So all the positive value will be correct. So the logic is like that.
Okay.
Okay?
Yep. Thanks.
Sure. So take this one. You spend 1 minute here. Later on, you go home. It means if you study, you save half an hour. Okay, so I stop here. Thank you very much.